The next step in stability analysis is the calculation of the flight modes in longitudinal and lateral directions. So for what follows, you'll need to be familiar with these concepts. There's plenty of documentation on the web on the longitudinal modes, which are in our case the Figurehead and the short period mode, and in the lateral direction there are the Lateral mode, the roll damping, and the spiral mode. And the purpose of what follows is to explain how we calculate these modes. The prerequisite to do this is to have a stable plane and to have this negative slope, this flying wing. And if we have that, then we can move on and define a stability analysis. So we get a new input form, which looks very much like the previous one. One difference which we can notice on this first page is that we only have a choice for one type of analysis, which is a mix of 3D panels and vortex lattices. The 3D panels are used by the body, and the VLM is used for the lifting surfaces, which are the wings, the elevator, and the fin. At this stage, let's leave unchanged these parameters, and we'll leave unchanged these also. We won't define any gain for the wing tilt and the elevator tilt, and we'll leave the other parameters unchanged also. Since we haven't defined any gain for the angles, we don't need to run a sequence of analysis. We only need to run one, and the control parameter doesn't make any difference to the results. So let's run this. We have been running this analysis on the test plane with the AG25. The analysis was really quick, and so let's see what's happened by pulling the log file here. So what does it say? Sorry. Right. Okay. It reminds us of what are the input parameters, the inertia parameters. It says that it has found a zero moment on angle, which is minus 0.15 degrees. Now let's check this. We are talking of the test plane AG25, and let's look at this brown curve, the T2 VLN2. If we look at graph number 3 here, it intersects the horizontal axis for a value of AOA, which is, let's look in the status bar. The status bar says minus 0.212, or maybe a bit more. Yep, minus 0.12. And that's the value for which the pitching moment is 0. Well, that's almost exactly the value which has been determined by the program as the zero moment angle. So that looks good. For this angle of attack, the speed calculated by the program is 21 meters per second. Let's check this also by changing the variable here. Minus 0, we are roughly at 21 millimeters per second, which looks good too. Let's move on. Here we have some longitudinal natural derivatives. We don't really use these values, nor do we use the state matrices. We just check that the longitudinal modes and lateral modes have been created successfully. These are complex values. I won't explain what they are or how they're used. This is a bit technical. But The important thing is that everything went smoothly and that the panel analysis completed successfully. So this is the green curve here. We'll use a color similar to the type 2 polar because they're closely related. So let's use this and have a thick line and use a big point here. So we've only got one point, which is where we expect it to be at the angle of attack minus 0.15 degrees roughly. And it's somewhere, it's always located, if the analysis went smoothly, on this red curve. I mean, you should always find them matching, and the point should be located at minus 0.15. So what extra information do we have? Well, we have the flight modes, and the best way to see those is either using the root locus diagram or the 3D view. Oh, so we didn't generate the operating point, that's my mistake. I should have stored the operating point, which I do now. And here it is. In the longitudinal direction, we have 4 modes. The first 2 are identical, and so are modes 3 and 4. Let's look at their shape by animating the display. Now we see that when I restart the analysis, and I'll run it very slowly, restart, we start at a position where the plane is not at its level flight steady state, and it goes back to level flight with pretty fast. We see after 0.200 milliseconds we have already returned at horizontal flight. So that's a stable mode, and it's called a short period mode. And the second one is exactly the same. Now, modes 3 and 4 will be the Figurehead mode. Depending on the analysis, you may find that 1 and 2 are the Figurehead and 3 and 4 are the short period. You cannot really tell in what order the program will calculate these modes, but you can really say by the look of them which is which. So let's look at the Figurehead and we'll animate it a bit faster. There we are. And let's look at it sideways. So if this were horizontal steady state, the plane would have this motion around steady state, and this is called the Figurehead mode. It's a sort of a, and this view is in the plane referential. When you see it flying, it will be a sort of a nose dive and a sort of a Russian mountain type of flight, going up and down. Well, once again, you should see or read some documentation on what is the Figurehead. Mode number 4 is the same. So this is not this is a stable mode, but it's lightly damped, and well, that's the kind of behavior you can have with offhand controls of your plane. Now let's look at the lateral direction. Here we'll find 2 Dutch roll modes, which we can look at in this view here. So let's see which is which. Number one is the roll damping. Let's run it very slowly. Restart. So we start with a rolling angle, and it goes back to horizontal flight. It's a bit similar to the short period mode, but it's in the rolling direction. Number 2 and number 3 are the Dutch roll modes. Now let's animate them a bit faster, these 2. And let's restart. There we are. So it's a sort of back and forth in roll and pitch, roll and yaw, sorry, behavior, and it's stable. Progressively, after 1 second or so, it goes back to normal. Let's do it again. If you look at your plane, depending on how stable it is in lateral direction, you could see this kind of movement around the nominal flight path. After you exit a turn abruptly, for instance, if you release your control abruptly, you might see your plane having this sort of behavior, especially if you have a small tail volume. Okay, and the last mode is a spiral mode. We have yaw angle, and progressively we increase this yaw or reduce it depending on the stability of the plane. But it's a very slow mode. You see, it doesn't animate very fast. We're already 4 seconds in the mode and it hasn't moved apparently. This is a mode you won't notice when you fly. It's too slow. Your controls are occurring at a much higher rate than this mode here, so you won't notice it. Okay,